BMonster Laboratory here. Today I'm going to show you how to make your own real-time clock using Arduino. We're going to put it on an LCD display. We're also going to use the Elegoo DS1307 RTC module. This also corresponds with Lesson 19 in the Elegoo Mega 2560 tutorial. So in this video I use a whole bunch of male-to-male wires, jumper wires here. I'm using a 1K ohm resistor, also using a 10K ohm potentiometer, one with a knob on the top. I like those, they're really great. I haven't been able to find a potentiometer yet that fits well on a breadboard, but this one seems to do okay. I did have to bend the pin a little bit. I'm also using a 1602A or 1602A LCD monitor. It's the 16x2. I've got a couple of videos on this, and I'll link one in the description below if you're interested in watching that. And I'm using the Elegoo Mega 2560 microcontroller. You can also use the Nano if you want. That works perfectly fine, and it has all the pins that you need, all the connections that you need. And I'm also using the Elegoo. This was in the Elegoo Mega 2460 kit that I purchased, and I'm using the DS1307 module V03. And there's a more popular one out there, but this is the one that was in the kit, so that's the one I'll be using. I'm also using a full-size breadboard here, and that is all you will need. That's all I needed. So this is the DS1307 real-time clock module that was in the kit, like I said. Now there's another DS1307 module that is a little more popular. It's the AT24C32 module, and I bought a couple of those off of eBay. It just takes a while to get to me. But that one has, instead of just one IC, it has this chip plus an EEPROM chip as well. So we'll see how that goes when I get that. But this chip has an IC right here, and this is the DS1307Z chip. This comes with a battery backup, so that if you unplug power from your circuit, from your board, it'll still keep time for you. This is the lithium CR1220. It's a 3-volt battery, and that's a great option. I like that. I like the idea that you're able to change it out too when it dies. But this one should last quite a while. So this is a 5-pin module, and when I received it, the header was already soldered on there. And as you can see, it's got a ground pin, and the next pin down here is a VCC pin. It runs on anywhere from 3.3 volt to 5.5 volt, and so I'm just supplying 5 volt to it. Below that you've got your SDA pin. Now that is a data input output pin for the I2C serial interface. And below that we have the SCL pin. The SCL pin is a clock input pin. It's for the I2C interface, and it's used to synchronize data movement on the serial interface. So the SCL pin is a clock input, the SDA is a data input. And if you look down here at the very bottom, this is an SQW pin, and this outputs 1 of 4 square wave frequencies and can be enabled by programming it. So you can program that. But that's not something I've used. Maybe sometime in the future, I don't know, but definitely not this time. So I'm just using these top 4 pins here. So when I'm connecting this module, I'm going to connect the ground to the ground pin, the VCC to the 5 volt, and the SCL and the SDA pin. If you're using the Mega board, you can see that pin 20 and 21, 20 is the SDA, 21 is the SCL. But if you're using the Nano, you're going to use the A4 and the A5 pin. So the A4 pin is the SDA, and then the A5 pin is the SCL. So you're just going to make sure that those connect to the right two pins. So the first thing I'll do is go ahead and connect my LCD module here to the breadboard. Then I'm going to connect my potentiometer right across the gap here. Make sure it's in there real nice and neat. It tends to pop up sometimes, but it's pretty sturdy. Then I'll just put in my RTC module right over here out of the way. And then I'll start making the connections. Here is a quick schematic that I created on TinyCAD, if that's helpful for you. So here's a code that I used. I just used two libraries. I used the one for the LCD module. I used the library for the I2C device, the RTC module. And a lot of what you see online, you'll see people use the library RTC library. I downloaded the one by Neuron, it looks like. Maybe I should have downloaded the one by Adafruit. Their stuff is usually pretty solid. I don't know if the issue was in the library itself for this, or whether it was something that I mistakenly typed into the code. I don't know, but it was very frustrating trying to get this together. So I went without the RTC library, and like I said, I just used these two. If you come down here, you can see that we got the seconds, the minute, and hour on our clock, and we also got the date, the month, and the year as well. So that's all I was shooting for this video, but this is what I've got, and I will include this code on the Facebook page. If you don't know how to get there, I will include a link in the description. And also, you can get there by clicking the Facebook icon on the Bee Monster Laboratory YouTube banner down on the bottom right If you click that, you'll go right to it. I'll include that code there and with a link to the video as well. So this code is it's a combination of about 5 or 6 examples that I saw online of the many examples. For me, this was a little hard. I don't know. Maybe for you it was a little hard as well, but I've developed another goal, and that is to learn C++. To actually learn it, be more than just familiar with it. I think it'll help a lot in the long run. Oh, sure, you'll be able to get by with just being familiar with the code. You'll do okay, but you'll never be great. You'll never be great at it unless you actually learn C++. You won't be good at solving problems. You won't be good at answering questions with the full understanding of what you're actually saying or what the question actually is. So for me, it was an eye-opener. So, new goal. Learn C++. Well, that's all I've got for today. Maybe you've done this or tried it differently. I'd love to hear from you in the comments below. As always, thank you very much for watching, and I'll see you again very soon.